In Module 8, we are going to start talking about quadrilaterals. And the first quadrilateral we're going to talk about is parallelograms. So its definition, a quadrilateral is a parallelogram if opposite sides are parallel. So when you're looking at a parallelogram, in order to figure out which sides are parallel, we look at the matching arrowheads. So in our picture here, we know based on the arrowheads, we have one pair. So that tells me that PQ is parallel to RS. And then when we have our two pairs of arrowheads, it tells me that QR is parallel to PS. And when it comes to writing out a parallelogram, we use a symbol that looks like a parallelogram. And then we name it. So parallelogram PQRS is read as parallelogram PQRS. Now we're going to talk about some definitions and theorems that have to relate to parallelograms. So first, parallelograms have four sides. That's the definition of a quadrilateral. It's any shape with four sides. The opposite sides are parallel and they're congruent. So in our picture here, not only is AB parallel to CD, they're also congruent. And then the same thing for AD and BC, they're parallel and congruent. Next, we have that opposite angles are congruent. So in our parallelogram, the opposite angles are angle B and angle C, so they're congruent, and then angle D and angle B. We also have that consecutive angles are supplementary. So remember, supplementary means adds to 180 degrees. So angles A and D add to 180, A and B add to 180, and then B and C add to 180, and then C and D add to 180. So supplementary, the consecutive angles aren't just the angles going down, they're also the angles going across. And then the last thing we have is that the diagonals bisect each other. So it splits them in half. So they're not necessarily congruent to each other, but they do bisect each other, which means AO is going to be congruent to OC, and then BO is going to be congruent to OD. Let's go ahead and do some examples. So in our parallelogram, the measure of angle QPS is 70 degrees. We want to find SR, ST, the measure of angle PQR, and the measure of angle QRS. We also have that PQ is 5 and QT is 3. So let's go ahead and QPS is this entire angle. It's 70 degrees. So I'm going to go ahead and label that. Now let's start finding our length. So SR. It is the opposite side to PQ, which means it's congruent to PQ, which means SR is also 5. ST is the rest of diagonal QS, and since diagonals bisect each other, QT and ST are the same length, which means ST is also 3. Next, we find the measure of angle PQR. So I'm going to go ahead and label. So angle PQR is consecutive to angle QPS, which means it's supplementary, which means it adds to 180. So when I do 180 minus 70, we get the measure of angle PQR is 110 degrees. Lastly, we have the measure of angle QRS. So QRS, label it, is the angle opposite QPS, which means it's congruent, so it measures 70 degrees. Okay. Second example, we know PQRS is a parallelogram, so we want to find x and y. So let's start with solving for x. We know that PQ is x plus 7 and SR is 3x minus 3. And those are opposite sides, and opposite sides are congruent, which means x plus 7 equals 3x minus 3. So first I'm going to subtract x from both sides. So we get 7 equals 2x minus 3. We're going to add 3 to both sides, so we get 10 equals 2x. Lastly, divide by 2, and we get that x equals 5. Next, we want to solve for y. So we know angle Q is 2y, and angle R is 3y plus 30. They're not opposite angles, but they are consecutive, which means they add to 180. So we know that 2y plus 3y plus 30 equals 180. So first I'm going to combine like terms. So we end up with 5y plus 30 equals 180. Subtract 30 from both sides. We get that 5y equals 150. Then we divide both sides by 5, and we get that y equals 30. Third example, we have that FGHJ is a parallelogram. We're given that FG is 5, GK is 3, and the measure of angle J is 70 degrees, and then we would find some missing measures. So first let's go ahead and label all of that. So FG is 5, GK is 3, and the measure of angle J is 70 degrees. So we want to find JK, which is the rest of diagonal JG, and diagonals bisect each other, so it also has a length of 3. Next, we want to find JH. It's the opposite side to FG, which means it's the same length, so it also has a length of 5. The measure of angle G. So angle G is opposite with angle J, which means they are congruent, so it has a measure of 70 degrees. And lastly, the measure of angle F, which is the consecutive angle to angle J or angle G, which means it adds to 180, so it has to be 110 degrees. Example 4, we want to solve for x, and then we want to find the measure of our angles W and Y. So angles W and Y are opposite, which means they are congruent. So 3x plus 18 is going to equal 4x minus 9. I'm going to subtract 3x from both sides. So we get that 18 equals x minus 9. Then we're going to add 9 to both sides. So we get that x equals 27. So our first step is done. We've solved for x. Now we want to find the measure of our two angles. So we know they're going to be congruent. So I don't have to plug x into both expressions. I just need to plug it into one. And I'm going to go ahead and plug it into the 4x minus 9. So we're going to have 4 times 27 and then minus 9. 4 times 27 is 108 minus 9. So the measure of angles W and Y are 99 degrees. Our last example, we're solving for x and y. So we have diagonals. Diagonals are not necessarily congruent to each other, but they bisect each other. So in order to solve for x, I know that 2x plus 6 has to equal 40. So we're going to subtract 6 from both sides. So we get 2x equals 34. Divide both sides by 2, and we get that x equals 17. In order to solve for y, we know that 2y minus 4 has to equal 16. So we add 4 to both sides. We get 2y equals 20. Divide by 2, and we get that y equals 10. So just to review, for parallelograms, opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary, and our diagonals bisect each other. So as you're working on the assignment, if you have any questions, please let me know.